January 2024, an A-50 stealth aircraft from the Russian Air Force was attacked during the operation. A short month later, another Russian A-50 was shot down in the air over the Asia-Pacific. The stealth aircraft's weak defensibility is gradually attracting people's attention. And on June 18th, the U.S. Air Force and the Australian military just conducted a joint training of the E-7A stealth aircraft. The E-7A is also the next generation of the U.S. military's main stealth aircraft. Today, let's talk about its performance on the battlefield. According to the Assistant Chief of Staff of the U.S. 10th Army Air Defense Command, the weapon used when the Russian A-50 stealth aircraft was shot down in January this year was the Patriot anti-aircraft missile provided by Germany to Ukraine. According to the Ukrainian military, another A-50 shot down in February was shot down by the Russian S-200 anti-aircraft missile. If it was shot down by a Patriot missile, it is understandable. Then the S-200 shot down by the Soviet era is enough to see the weakness of the stealth aircraft. The stealth aircraft's self-defense ability is not strong. After being locked by the missile, it is difficult to carry out other aggressive maneuvers except to release the fuel. But the stealth aircraft is very important. The entire long-range warning radar system can search and monitor the air or sea targets, command and guide several aircraft to carry out combat missions. From the name, it can be seen that the biggest function of the stealth aircraft is to find the enemy's target as soon as possible. In a war, if one side can always find itself earlier than the enemy, it is equal to half the victory. Because of this, the continuous loss of the A-50 stealth aircraft has an indescribable impact on the Russian Air Force. The A-50 can provide important reconnaissance and command functions for the battlefield troops. As a stealth aircraft, it not only helps troops to detect, but also helps several aircraft to carry out missions. The E-7A is a new stealth aircraft developed by Boeing, codenamed Z-Way. Its monitoring performance is very strong, and it can meet the needs of the anti-missile and can track more than 3,000 air-to-sea targets at the same time. If it does not pursue the extreme environmental performance of high-altitude reconnaissance, as long as the E-7A takes off and starts working, it is already monitoring 1/3 of the territory of Australia. The platform of the E-7A Z-Way stealth aircraft was modified from the Boeing 737NG type passenger aircraft. The maximum range is 13,000 meters, and it uses a multi-wave, multi-function radar from Grumman. This radar is more efficient than the E-3 stealth aircraft's multi-wave radar. Not only does it consume less electricity, but also the detection range is further expanded. When flying at an altitude of 9,000 meters, the detection range of the E-7A can reach 850 kilometers, and the lowest detection range of the combat aircraft target is 370 kilometers, and it can command 24 aircraft at the same time. Let's pause for a moment and talk about the importance of the stealth aircraft's flying height. The working principle of the stealth aircraft is actually very simple, which is to move the entire set of radars that the combat aircraft cannot equip to a higher altitude near the battlefield. This is equivalent to an expedition team moving forward in the dark. Although everyone has a flashlight, the captain's first searchlight is the farthest and brightest. The captain is not only 2.2 meters tall, but also has a particularly large flashlight in his hand. However, no matter how strong the radar of the stealth aircraft is, it also relies on the radar to play a role. The radar wave is a straight line, and the surface of the Earth is curved. Although it can't be seen with the naked eye, for a group of combat aircraft that has crossed hundreds of kilometers, the curvature of the surface has gradually appeared. The curved surface will limit the detection range of the ground radar. In order to make the radar detect further, the radar must be in a higher position. This position is not necessarily the height, but the height of the surrounding ground should be as large as possible. Therefore, general large radars will be set up on a relatively open, covered high ground. If the deployment is by the sea, it can also reduce the signal block brought by the terrain factors. But if you think about it carefully, the world's first peak altitude is about 8,848 meters. Just relying on the terrain to deploy the radar, the detection range of the radar is locked. After all, no matter how high the mountain is, there will be no aircraft flying so high. So the ground radar will be limited by the curvature of the Earth, and the detection range of low-altitude targets is limited, and it is easy to be disturbed by terrain. And the pre-alert system puts the entire radar system on the plane. By flying high, searching all kinds of air, sea, or land targets from the air, you can get a better pre-alert and search effect. After understanding this, let's look back at the E-7A pre-alert system, and you will understand the significance of it to the U.S. Air Force. Even if it is not the largest flight altitude, considering the practicality of the E-7A, it can also be stationed at an altitude of 12,500 meters to spy on the enemy situation for friendly aircraft. After the E-7A was deployed in Australia, it has successfully tracked the cruise missiles, ballistic missiles, and satellite launch activities launched by other countries many times. This is enough to show the strength of this pre-alert system. It has been selected and ordered by the UK, Australia, South Korea, and Turkey. On the contrary, the United States, which is a manufacturing country, has not purchased a new pre-alert system for various reasons. This is, of course, unimaginable. The United States, which has the most advanced fighter jets in the world, has not purchased a new pre-alert system for 30 years. Until a large number of E-3 pre-alert systems are about to retire, the United States began to gradually accelerate the E-7A pre-alert system plan. According to the U.S. military budget for the year 2023, the U.S. military has provided $2.27 billion to the Air Force to support the replacement of E-3 pre-alert systems. The budget proposal mentions that the U.S. Air Force will first retire 15 E-3s and will use and maintain the funds originally used for the pre-alert system to pay for the cost of the successor model, that is, Boeing's E-7 pre-alert system. The current E-3 of the U.S. military has not met the actual combat requirements of the Air Force, so it is no wonder that the U.S. Air Force signed the initial contract to purchase E-7A pre-alert aircraft in 2023, and before the aircraft arrived, it was going to conduct joint training with the Australian Air Force's E-7A. In 2022, the U.S. Air Force officially chose E-7A as the replacement for the E-3 Schaubing aircraft. But due to production problems and procurement funds, the project progress is not fast. It had already made a request to Boeing. The new pre-alert aircraft will be a brand new version of the E-7, and it will be dedicated to the U.S. military. If the plan is carried out on time, the first E-7 dedicated to the U.S. military will officially enter service with the U.S. military in 2027, and the United States has many military allies that can now use the E-7A of Australia to develop a new combat model for the U.S. Air Force. As long as the U.S. version of the E-7 is in service, the Air Force does not need to spend too much time adapting to quickly form a combat system. At the same time, the U.S. Air Force and the Australian Royal Air Force have agreed to expand the exchange plan. People from the Australian Air Force, the Navy, and the British Royal Air Force will help the U.S. military to adapt to training in advance to support the E-7 aircraft in service with the U.S. Air Force. Compared to the E-3 pre-alert aircraft of the U.S. military, the E-7 is first different in appearance. It no longer carries a round plate radar that looks like a big pot lid, but installs a new type of balanced wood radar. Because the E-3 pre-alert aircraft uses a traditional round plate radar structure, the radar will be scanned 360 degrees in the radar image in a mechanical rotation way. And the radar antenna will use a double-sided back-to-back structure to be placed on the axis of the entire plate. The advantage of this radar arrangement lies in the high utilization of space in the entire radar image. The length of the front of the radar can also be maximized, thereby significantly increasing the launch power of the entire radar and the detection distance. To some extent, this can also improve the multi-target processing ability of the radar. But then again, the shortcomings of doing this are also obvious. That is, the radar antenna must rely on the mechanical structure to generate horizontal rotation to achieve a 360-degree full-angle detection. And those rotating antennas can't always keep a close eye on the target. Once it turns from the direction of the target, if it wants to track the target again, it can only wait for the radar antenna to turn back. This inevitably increases the probability of losing the target. Of course, the mechanical scanning array of the round plate radar is also very fast when rotating. It can complete a scan every 10 seconds. It's just that compared to the speed of a fighter, even if you look at it again after 9.9 seconds, the enemy's aircraft may have moved a lot. This kind of scanning frequency can't be reassuring. In contrast, the Y-7 Seaway precursor has an obvious advantage in terms of radar. To some extent, it can make up for the shortcomings of the Y-3 precursor. Its anti-aircraft radar is placed on the back of the aircraft. The length of the front is more guaranteed, so the area of the antenna is also easy to enlarge. And the larger front means a stronger launch rate and a further detection distance and a better multi-target tracking ability. Even if the platform is not large, it can also achieve more ideal comprehensive performance, because the active scanning array radar does not need mechanical rotation to monitor the target. But if you only install a vertical radar, the shortcomings are also very obvious, because this can only detect the targets on both sides of the fuselage. In order to gain full detection ability, it is necessary to install the corresponding radar antenna at the head and tail of the aircraft. In order to avoid such shortcomings, the Y-7 precursor has a very distinctive scanning antenna array. A vertical one is installed at the top of the aircraft, which seems to add a high-level vertical tail wing to the aircraft. The other is placed at the top of the vertical tail wing. We think it is some kind of support structure. In fact, it itself is a radar array. In this way, two antennas form a T-shaped structure, which can be used both horizontally and vertically, and has a very good downward effect. The world of vertical antenna is about 240 degrees, and the world of horizontal antenna is about 180 degrees. This makes up for the shortcomings of only vertical radar. The Y-7 can theoretically achieve 360-degree full directional detection. This layout can minimize the obstruction and interference of fuselage to the radar wave and ensure the search effect of high-power radar. In addition, the two radars provided by Grumman for the Y-7 are advanced. This multi-wave active electrical scanning antenna array radar has more than 5,000 starting antenna units and has 3 detectable modes. In the standard mode, it can detect nearly 400 kilometers of area at 360 degrees. In the enhanced mode, the radar can detect targets at 600 kilometers in the focus area. The Y-7 can also operate the focus mode and carry out large power focus scanning for a specific area of nearly 1,000 kilometers to ensure that it does not miss local targets. Even if it encounters sudden bad weather conditions, the Y-7 can also work under pressure. It can track and analyze 180 targets 600 kilometers away under any weather conditions. At the same time, it can coordinate more than 20 aircraft to carry out tasks. It can also carry out 10 more complex aerodynamic analysis tasks at the same time. The existing Y-3 antenna of the U.S. military is already difficult to use in such a high-resistance environment. It lacks the network and intelligence integration processing capabilities and is difficult to meet the needs of the U.S. military. And the Y-3 antenna's fuselage is seriously aged, especially the parts of the fuselage platform have stopped production, which has brought greater difficulties to platform maintenance. And compared to the Y-3 antenna of the old 4-engine platform, the new 2-engine fuselage, Y-7 uses the very successful Boeing 737 NGK fuselage. This brings the aircraft a worldwide perfect logistics security supply chain. Although the Y-7 antenna's fuselage is relatively small, the maximum takeoff weight is 77 tons, which is almost half as small as Y-3. But the 6,500-kilometer route is only less than 20% shorter than the one Y-3 antenna's 7,400 kilometers. The Y-7 antenna's fuselage can accommodate more than 10 command and control stations. Compared to the Y-3's machine-operated processing computer and display controller, it is undoubtedly an advanced aero platform, which is more powerful, more efficient in operation and maintenance costs. Considering that the Y-7 version obtained by the U.S. military will be a new and stronger improvement, the new Y-7 will definitely have a lot of highlights. The Army will also follow up on the analysis at that time. As for what changes the Y-7 can bring to the U.S. military system, please leave a comment in the comment section. Like and subscribe my channel. See you next time.